Good evening and welcome to Mrs. Spencer's Math Lab. If you're returning, then I'm glad to have you back again. If you're new, welcome to my Math Lab. Today we're going to be working on some basic number concepts. I have a question for you. How many of you would like to be millionaires? I can't hear your answers, but I'm sure you're saying yes. How about multimillionaires? And I'm sure you're saying yes to that. I'm going to put some money up on the board. Okay. And I'm not going to read it to you. I want you to write that amount down in words on your paper that you have. And I'm sure if your first time looking today, I'd like for you to get some pencil and paper because this is not a lecture. I want you to be involved in what we do. So write that number down and then write the words for that number. If you're going to say, I have this amount of money, how much money do you have? So I'm going to wait a few minutes and see if you can tell me. Numbers are really nice, fun to work with. And notice I have all fives. Those are digits that make up the number. So I have 3, 6, 7, 8 digits that make up the number, the amount of money that we'd all like to have. All right, I'm hoping that you have written it down, and I'm not going to tell you right now what it is, and we'll wait and see, and you may want to change it. So today we're going to look at this number and sort of dissect it and see, bisect it and dissect it and see what it's really about. So today we're going to talk about place value and place. Notice there are two different things, and sometimes this can be very confusing for students. Because when you're asking them for the place, they think you're asking them for the number. And when you're asking them for the number, place value, they give you the place. So let's say that whenever I ask you for the place value, when you see the word value, I want a number. And when I ask you for the place, I want a word. And that makes sense, doesn't it? When I ask for the value of something, then I want to know a numerical answer. And when I ask for the place, I want to know its location. All right, so let's look at the location of these numbers. All right, I'm going to put something up here that I'm sure most of you are familiar with. All right, these are place. This is a part of a place value chart. And this is the ones family. Just think about it like a family of yours. And these are the members of the family. It has 3 members. The ones family has one member called the one called tens, and one called hundreds. All right, so this tells us the location of these digits. So this 5 is in the ones. The second 5 is in the tens place, and the third one is in the hundreds place. All of these are 5s, but because they're in different locations, each one has a different value, place value. So we're going to talk about the values of each of these and see how well you do with it. And so this should take care of people in lower grades right on up to pre-algebra, really, where you start writing with scientific notation, because this would be one that we would probably put in scientific notation as we get higher in math. All right, so let's look at this first 5. All right, it's in ones place. So that tells, I can tell the value of that 5 because I'm counting 5 ones. It's just 5. 1, 2, 3, 4, 5. All right, so the place is ones, and the value of that 5 is 5. All right, let's move on to the second one. The second one is in tens place. So that means we have 5 tens. And most of us learn to count by tens early. So 5 tens, 10, 20, 30, 40, 50. All right, so that's 5, 0. So that's 50. All right. The third 5 is in hundreds place. All right, and that tells us how many hundreds. So that's 5 hundreds. What's the number for 5 hundreds? 5, 0, 0. All right. So if we were reading just this part of the number, what would that be? 555. And we don't say ones. It's in the ones family. But this is the only family of numbers that on the place value chart that we don't say 1 1, 10 ones, 100 ones. We don't do that. So we don't say the ones. That's the only one in the place value system that we don't name the last name. It's like a family. The last name of this whole family is the ones. All right? So this part is 555. All right, so I hope that's the last thing you wrote when you were identifying this number. All right, let's move on. Then we have the next family, which is called the thousands family. The thousands family. Okay? So we look at that and we see the family name is thousands. And again, each family has just 3 members. The thousands, and notice just like the ones were named, the first member of the ones family was ones. The first member of the thousands family is thousands. And the second member of the ones family was tens. The second member of the thousands family is 10,000. The third member of the ones family was hundreds. The third member of the thousands family is 100,000s. So it's sort of repetitious. So if you know one, you sort of know the other. All you have to remember is the last name. So this takes care of the next 3 digits. So the first 3 digits were in the ones family. Now we in the thousands family. All right. This first 5 is in thousands. So that would represent what? 5,000. And I'm saying a number. All right. That's 5,000. All right, counting by thousands, count 5 of them. Those of you in the lower grades, 1,000, 2,000, 3,000, 4,000, 5,000. So that's 5,000. All right, the next member of the thousands family is the 10,000s. 10,000s. All right, so I'm going to try to move this over so we can do this. All right. All right, so we have 5 10,000s. So we say 10,000, we say 10,000, 20,000, 30,000, 40,000, 50,000. And I have a reason for putting them down like this, because I want you to see the pattern of this as well. All right? And the next one is 100,000. All right? So it's 100,000, 200,000, 300,000, 400,000, 500,000. All right. All right, so now, how would we say this? So far, looking at that much of the number, just that, is 555,555. Okay, so we're almost there to identify what the number is. All right, so we have another family, because there's only 3 members in each family. And the next family is called the millions family. And guess what? They have the same names. The first one in the millions family is named after the family, millions. The second one is named 10 millions. And the third member is named 100 millions. 100 millions. All right, so it worked out that they all have the same pattern. The first member of the family is named after the family name. The next one is 10. And the next one is 100. So let's see what we have up here. All right. So this then is in thousands place. It's in millions place, I'm sorry. All right, and it's 5 million, so let's count by millions. 1 million, 2 million, 3 million, 4 millions, 5 millions. All right, so this is 5 million. All right. All right, so we have 5 in millions place is 5 million. All right, and the last one is in 10 millions place. So we count by 10 millions. 10 million, 20 million, 30 million, 40 million, 50 million. All right, so we have 5, 0, 0, 0, 0, 0, 0, 0. And while I'm thinking about it, let me tell you something about 0 that bothers me. When I hear people use 0 for a telephone number, instead of saying 0 for a telephone number, you say O. O is not a number. O is not a substitute for 0. Because on the telephone, O matches the number 6. Check it out. O on the telephone does not match 0. It matches the number 6. So let's not say, I'm being a mathematics teacher. When people tell me a part of their phone number is something O, then I want to know your phone number has both numbers and letters. And if it has letters, then the letter that represents the O is 6. So let's say 0. That's a good replacement number. 0 means nothing, but depends on where it is as to what you have. All right, so let's look back at what we have. We have 55 million. 55 million, if we look at this whole thing now. 55 million. So what did you write? I hope you wrote 55,555,555. How many of you wrote that? Because if you're going to be a millionaire, you got to at least know how to write your checks out right and know how to use your money and know the values of it as well. All right, so let's backtrack and make sure we're on the same page. All right, the first family here is the ones family. We have ones, tens, and hundreds. All right, the second family here is the thousands family, and we have thousands. Okay, 10,000s. All right, 100,000. Not doing so good writing sideways. All right, then we're now through with those three. Now we're in another family, the millions family. And the first one is millions, and the next one is 10 millions. All right, and so you see a pattern. In the ones family, the first one is named ones. In the thousands family, the first one is named thousand. In the millions family, the first one is named millions. The second family in each one is tens. Tens, 10,000, 10 million. And the third one is hundreds. 100,000s. And if we had another number over here to complete the millions family, then it would be 100 millions. So if you read this number right, you read 55,555,555. That's why it's important to know place value. I purposely put all the same digits up because I wanted to get a concept over to you that the digit, where the digit is, determines its value. If a digit is in ones place, it's 1. If the digit is in tens place, it's that number times 10. If it's in hundreds place, it's that number times 100. If it's in thousands place, it's that many thousands. If it's in 10,000s place, you're counting by 10,000s. If it's in 100,000s place, you're counting by 100,000s. And if it's in millions place, you're counting by millions. 1, 2, 3, 4, 5. And if it's in 10 millions, you're counting by 10 millions. 10, 20, 30, 40, 50 millions. All right? And notice something else. Sometimes you'll ask, in grade school especially, to write this number in expanded form. Expanded form means that you are writing just what I wrote here. You're writing the number, but you start writing that from left to right. So I would write first 50 million plus 5 million plus 500,000 plus 50,000 plus 5,000 plus 500 plus 50 plus 5. And that's called the expanded form. So all you're doing is giving the values of the numbers from left to right as you read the number. All right? So I'm sure most of you were able to write that number, and it would be nice if we could write that number on a check or have that in our bank account. So I'm going to give you a couple of numbers, and I want you to see if you can write it in words and then write it in expanded form. All right. I'll start with something easy first to get those in the lower grades. All right. I'm sure those of you in upper grades and adults know exactly what that is. But I want you to write it in expanded form for me. And learn to spell the number words right. That's something we need to do. 1 O-N-E, 2 T-W-O, and so on. And when you write like 38, you write a hyphenated number. So I'm going to write this one out. All right. So this is 5. This is in the ones family. 500. 30, THIRTY, hyphen 8, EIGHT. All right, 538. It's ones family, so we don't say ones. We just say 538. All right, now let's do another number that's a little bigger. All right, write it in words. And what we do when we read a number, we read from left to right, and we read the number, and this comma tells us that's the end of that family, so we write the family name, and then we write the rest of it. All right, so in the millions family, we have 27. All right, so write 27. Thousands family. I think I said millions. 27,000. Okay, 402. And you notice I'm not saying and. Please don't say and. And it's going to be used when we get to decimals. Don't say 402. That's not correct. And sometimes I hear a lot of people saying that, but that's not really the correct way. It's not 402. It's just 402. So if you had an and in there, scratch it out. It's 27,402. All right, now go ahead and expand it for me. So you start with the 2. First, you have to know what place it's in, and then it tells you the value, and so on. All right, so we have the 2 here is in ones, tens, hundreds, thousands, 10,000s. So that's 2 and 1, 2, 3, 4 zeros. 1, 2, 3, 4. So that's 20,000 plus ones, tens, hundreds, thousands. So that's 7,000 plus ones, tens, hundreds. So that's 400 plus 0, and we don't need to write that. 2 ones. So that's 2. So this is the proper way to write that. If we have 0, we don't need to write it. But if I was telling you that number, you'd have to put that 0 there. Because it has to have, the family has to be complete before we go to another family. Now the only family that can be incomplete is the first family on the left, I have a left and right problem because I was born left-handed and made to write right-handed. So I have to catch myself with left and right. All right, so we read the number from left to right. So this is 27,402. And that means it's 20,000 plus 7,000 plus 400 plus 2. And if you notice, it's a pattern. Here I wrote the 2 and 1, 2, 3, 4 zeros. Here I wrote the 7 and 1, 2, 3 zeros. Here I wrote the 4 and 1, 2 zeros. And nothing for the 0. And 2 is just 2. All right. If you have a question, shoot it, because I know parents have to help students with this. And I've tutored some students who have quite a time with this. And because they get the value mixed up, they get expanded mixed up. This is called the standard form of a number, the way we generally write it. This is the expanded form. This is the word form. Again, this is the standard form. And we did not write the expanded form for that. That if we did, that would be 5 in hundreds place. So that's 500 plus a 3 in tens place is 3 tens, which is 30, plus 8. So this is the standard form. This is the word form. And this is the expanded form of the number. All right. I hope that makes that clearer for somebody who's been having a problem with their child and working with that. Because they do that up until the 5th grade, I believe. And then we get in scientific notation. We really don't have to work with that. We just have to work with the form for scientific notation. All right, so much for that. Okay, so now that we know what the place value is, we have the ones family, we have the thousands family, the millions family, the billions family, the trillions family, and then we go on. But basically, we don't go with all of those. All right, the ones family composed of ones, tens, and hundreds. The thousands family composed of thousands, 10,000s, 100,000. Today at the millions family, it's composed of millions, 10 millions, and 100 million. So each family is composed of 3 when it's complete. All right? And that means we put a comma there. That's why we put the commas there. So I'm going to ask you to write a number now. I'm going to say it to you, and I want you to write it, because it's the same principle as it is in reading. All right? Ready? All right. The number I'm going to give you, and I need to write it down so that I remember, is 62,598. 62,598. And I want you to write that in standard form. Write that in standard form. 62,598. All right, I'm sure you've completed that. Now watch me do it, because I want you to see what I'm saying here. 62,000. See, that means I've completed that, the part of that family. All right, 62,598. All right. Now I put that in expanded form. All right, so this really tells us what a number means. We put a number up and we have no number sense. I used to tell my students, your number sense is just missing. Let's get it going. Let's not be number crazy. All right, so we have 6 is in ones, tens, hundreds, thousands, 10,000. So I need to write 1, 2, 3, 4 zeros. Plus the 2 is in ones, tens, hundreds, thousands. So I write 2. And I need to write 1, 2, 3 zeros. I hope you're seeing the pattern that I'm trying to show you here as I write. I'm coming down on the next line. The 5 is 1, tens, hundreds. So that's 500. The 9 is in ones, tens place. So that's 90. And the 8 is in ones place, so that's 8. All right, were you able to do that? And parents, I hope that you see the pattern that I'm showing you here and how each time I locate the place to find the value. And so that you can help your child with that. All right, I'm going to give you one more number to write. And then we're going to do something else with these numbers. All right, this time I want you to write 304,608. 304,608. Write it. Don't listen. If you're listening to it, you need to write it as I say it. 304,608. All right, now watch me write it as I say it, and you'll get what I'm saying here. All right, 4,000. See, that lets me know I've finished the family when I say that name of that family. 608. And I have to have that 0 here because I have to have something in. If I have to have something in this to complete this family. This is the first family on the left is the only family that can be incomplete. But the families on the right has to be. So I couldn't go to millions until I had completed the thousands. And let's know that because some students leave out that 0. It has to be there. You have to have ones, tens, and hundreds before you go to thousands. And thousands, you have to have thousands, 10,000s, 100,000s before you can go to millions. So you have to have complete families leading up to the last family. All right? So I hope you have written that correctly. And I want to go to some other concepts. All right, another thing we do with these numbers is, which is very important, especially if you're going to do groceries, if you are trying to decide your budget for the month, you don't have to be exact, but you can use estimation. And that's something that, estimation. All right. If you have a long list of numbers and you want to get a quick idea of how much something's going to cost, or if you're multiplying and dividing, subtracting, and you want to get a ballpark figure, we use estimation. Estimation deals with rounding a number off. Well, what do we mean rounding it off? Expressing it to the nearest place. If we say we want to express it to the nearest hundreds,
estimation.
If we say, thank you. If we say we want to round it off to the nearest 10, or the nearest 1,000, or the nearest million, whatever it is. All right, so let's talk about rounding off. All right, so I'm going to talk first about rounding off to the nearest 10. And I'm going to do a little number line here. So you can do that too. All right, so let's do 10. All right, so a number between 10 and 20. Okay. Number between 10 and 20. All right, so we're going to write them. 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, all these should be the same distance, but they're apart, but they're not quite. All right, so when we say we're rounding off, all we're saying is which one is closest to. Is it closer to 10 or is it closer to 20? And of course, you can look at that and see 11 is definitely closer to 10. So 11 is approximately 10. 12 is closer to 10 than it is to 20. So that would also, 12 would also be, and it's not equal. I noticed I just did a little swivel mark. That's closer to 10. 13 is closer to 10 than it is to 20. Okay. 14 is closer to 10 than it is to 20. Now, 15. I want to talk about 15. Well, 1, 2, 3, 4, 5. It's 5 spaces from 10. 1, 2, 3, 4, 5. It's 5 places from 20. So you can't say 15 is closer to 20 than it is to 10 because it's exactly halfway between. But mathematicians have decided when it's halfway that we will go to we would call what we call round up. We'll go to the upper number. So we're going to say 15, and I'm going to put 15 over here. We're going to round that off to 20. Not because it's closer to 20, because it's exactly halfway between. It's just a decision that we have made as mathematicians so that everybody will do it alike. All right, so it's obvious that 16 is closer to 20. 1, 2, 3, 4. Than it is to 10. 1, 2, 3, 4, 5. All right, so 16 will round off to 20. 17, of course, is even closer. 17 would round off to 20. 18 would round off to 20. And 19 definitely would round off to 20. So I haven't given you a rule, but I think you see a pattern. All these numbers are closer. 1, 11, 12, 13, 14, definitely closer to 10. 15 is halfway between, but by mathematical decision, we go to the higher one. And when it's there, we go to the lower one. All right, so let's do 30 and 40. You make your number line while I make mine. $30 and $40. All right. I'm going to put this little halfway mark in there because that's going to be 35. And then I'm going to have 1, 2, 3, 4, 6, 7, 8, 9. And I'm going to put that 40 a little closer. 40. All right. So I didn't write all the numbers between, but we know this is 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. All right? So I'm going to put some of the numbers so that you can keep track. 32, I'm going to put 37, and that's 38 and 39. Okay, so it won't get so many numbers up there that it looks junky. All right, so we're trying to round off to the nearest 10. So the third 10 is 30, and the fourth 10 is 40, counting by tens. So all of these numbers are between 30 and 40. All right? So we just found out that everything that's below the halfway mark is rounded down. So that means, and everything from the halfway mark up is rounded up. Okay, that's one thing we found in our last problem. All right, so that's here. All right, so 31 is approximately 30. 32 is approximately 30. 33 is approximately 30. 34 is approximately 30. 35 is halfway, but we round it up. 36 is rounded to 40. 37 is rounded to 40. 38 is rounded to 40. And 39 is rounded to 40. All right, so without a number line, if I gave you the number 56 and told you to round it to the nearest 10, so you know that this is between, this 10 is 50, and the 10 next to it is 60. Which one would it be closer to? Okay, I hope you said 60, not because I wrote it closer to it, but because it's over half. What's the half between 50 and 60? 55. All right, if I gave you 59, that's approximately what? 60. If I gave you 53, that's approximately 50, and so on. All right, so if I gave you any numbers, then rounding off to the nearest 10, you ought to be able to do it. So and I haven't given you a rule, but I think it's obvious, but I'm not going to give you the rule until I'm sure you understand the principle of it. All right, so let's do 73. Let's do 85. Let's do 98. Round them off to the nearest 10. And so that means that's the 10th place. All right. 73 is between what two tens? 70 and 80. 85 is between what two tens? 80 and 90. 98 is between what two tens? And I hope that didn't catch you. I'm not going to give you the answer to that. I'm going to just see what you do. All right. 73 definitely is closer to 70 than it is to 80. 85 is halfway between 80 and 90. So we round it off to 90. 98 is between 90 and 100. Did you get that? 90 and 100. And of course, it's definitely closer to 100. Okay? All right? So 100 is 10 tens. All right? And this is 9 tens, which is 90, and the next 10 is 100. All right, I'm going to give you one other one that I haven't talked about. Okay, suppose I had 163. Still rounding off to the nearest 10. So it's between what? 16 tens and what? 6 tens. Well, I'll say it this way. I could say it that way too. 6 tens and 7 tens. So it's between 160 and 170. And it's closer, of course, to 160. All right, if I lost you anywhere, let me know. Let me know. If you have, please put a question mark. All right, so rounding to the nearest 10, we see that we're just seeing what number it's closer to, which 10 it's closer to. And we round off to the one that it's closer to. We could round off to the nearest 100, and it would be the same principle. Without my saying anything, just to see how many got the principle, I'm going to do 432. And that's between 400 and 500. All right. What's halfway between 400 and 500? Okay, 450. All the halves in this number system begins with a 5. So everything below 450 is approximately 400. Everything above 450 is approximately 500. All right? So they have a rule, and the teachers teach the rule before they teach the principle. I'm hoping you realize that I'm talking about how close a number is to another number. So I didn't want to give you a rule. But when you're rounding off to a number, certain place, you look at the digit next to it. So if I'm rounding off, and I'm going to erase this, if I'm rounding off to tens, then that means I'm going to have tens and ones. So I could have a number like 63. All right, I would underline this, and I look at this number in the ones. If it's a 3, I know it's closer to the lower number because that's between 60 and 70. So 3 is closer to 60. 63 is closer to 60 than to 70. 65 is halfway between. All right, so if I'm rounding off to tens, I have to determine whether the next digit is 1, 2, 3, or 4. Because that will tell me, and all the halfway marks begin with 5. So the rule is that if the number next to the digit you're rounding off to is 1, 2, 3, or 4, you round down. That means you're going to take the lower number. All right, if it's 5, 6, 7, 8, or 9, you're going to round up. And this is what we talk about, round up and round down. In other words, you're going to take the larger number. Or if it's 1, 2, 3, or 4. So let's estimate something. All right, you have 532 plus 780. All right, so if I'm going to round off to help me, I don't want but one digit. So this is between 500 and 600. So this is approximately 500. And this is between 700 and 800. And this is an 8, so that's 780. That's going to be closer to 800. So this is approximately 1,300 or 1,300. All right. Now, some students will, when you say estimate, they will add it up and then round it off. No. Estimation just tells you to round it off. Then they may ask you for the exact value. And the reason we do this is so that we can see if our answer makes sense. Because sometimes we get a way off answer and it makes no sense. But we could determine that because when we actually add this, we get 2, 3 and 8 is 11, 6 and 7 are 13. So we see that's in the same ballpark. So that's a good method for checking your answers to sort of see if it makes sense. And again, if you're making a grocery list and you know how much stuff costs, you don't have to add up the exact values to know how much money to carry out or how much you're going to spend. Do an estimation. All right, you can estimate quotients, sums, differences. You can estimate products. All right, so let's estimate a difference. All right, something you have $6.59 and something costs $4.36. And you want to see about how much money you're going to have left. I'm going to put the dollar sign here since I said money. And I'm going to estimate. All right, so $6.59 is closer to what? $7. Okay, $4.36 is closer to $4. So I know I'm going to have something in the neighborhood of $3. All right, so estimation is really a neat way to sort of, number one, check to see if your problem is making sense. And in real life, to really handle some numbers and not have to do the exact amount, but to get a good ballpark figure so that you know, for example, if you have enough money in the bank. So you know, for example, if you have enough money for groceries. So estimation is really a good thing that you can use. All right, my time is almost up. So going back to what we've talked about today, we talked about, first of all, reading numbers, writing numbers, and we read or write them. We read the number that's in the family. When the comma comes, that tells us to say the family. And then we continue till we finish. And then writing it is the same. We have to have 3 members in every family except the last family on the left. That family can be incomplete. But before we can do thousands, the ones family has to have 3 members. Before we can do millions, the thousands family has to have its 3 members. The ones, the tens, and the hundreds. And everybody named their children the same thing in these families. The ones family named theirs ones, tens, hundreds. The thousands family named theirs one, tens, and hundreds, except they are thousands. And the millions family named theirs ones, tens, and hundreds. So I'm saying words. All right. Anything in the ones place is equal to itself. Anything in the tens place is 10 times that number. Anything in the hundreds place is 100 times that number. Anything in the thousands place is 1,000 times that number. All right. When I ask for a place, I'm looking for a location of the number, whether it's in ones, tens, hundreds, thousands. When I ask for place value, I want a number. I want to know what the number represents in the place that it is in. All right. And then I talked about rounding. Rounding is just seeing how close a number is to 2 other numbers. If we talk about tens, it would be between 2 tens, the successive tens, like 20 and 30, like 30 and 40, like 40 and 50, like 50 and 60, and so on. If I'm talking about hundreds, it'd be between 100 and 200, 200 and 300, 300 and 400, and so on. And so we learned that when we have the digits next to it, suggests that that it's 1, 2, 3, 4, we round down. We go to the lower number. When it's 5, 6, 7, 8, or 9, we round up. And remember, don't say 5 is closer to the upper one than it is to the lower one. It's just a decision that has been made. It's just as close. The halfway mark is just as close to the lower as the higher. But mathematicians decide that we would round up when we have that amount. All right, and then we can use rounding off to estimate. And that's the day we just estimated a sum and a difference, but we can also do that with division and multiplication. So sort of see if we got a sensible answer. And again, if we are doing it in real life, parents and other adults, we can certainly check to see if we have enough money in the bank, if we have enough money for groceries, if we have enough for sewing, if we have enough material, and whatever we can do that we need to do estimation to sort of get a ballpark figure to see how much of something we need or how much of something we have. All right, I hope today has been beneficial to you, and I just think I reviewed it for some upper grades, and the lower grades, I hope that you understand a little better about basic number concepts. Have a great week, and I hope to see you next week. And we're going to do two-step equations. So be ready to do some two-stepping next week with some equations. Have a good week.